All right. Well, welcome everyone. Thanks for joining us today on our first Snitch AI webinar. We're pretty excited. My name is Simon Shanks. I'm a product marketing manager here at Snitch AI. We've got some really good content for you guys. I know Olivier worked hard on his presentation. We're just gonna wait a few seconds here while people are trickling in slowly. A few things on the webinars today. It is recorded, so we will be sending the recording later on today. You can rewatch it. You can share it with your colleagues if you want. For those that couldn't make it today and that are watching in the future, feel free to send us any questions by email after watching the recording. For those that made it today, we will have a live Q&A at the end of the presentation. So at the bottom of your Zoom windows, there's a Q&A section. So feel free to shoot any questions as they come through during the presentation. We will only be answering them at the end of the presentation, though. But we will say for as long as you guys have questions. So feel free to shoot as many as you want. And perfect. So people seems to have trickled in. So let's get started. Olivier, the floor is yours.
Good. Hello, everybody. Thanks for being here. My name is Olivier Blais. So here is my self-presentation. My name is Olivier Blais. I'm head of data and transformation at Move AI. We're a consulting company in data science. And I'm also a CPO at Snitch AI. So I worked with the Snitch team in order to develop an AI quality evaluation tool. I'm also currently working with the ISO standards through the Canadian Standard Council of Canada, so the Standard Council of Canada, on quality evaluation. So we're currently working on making a project available on quality evaluation. And I'm also a guest speaker talking about AI and what AI can do in business context. So I've been working on several different projects in my other lives and also through the last years. Excellent. So today, I think, and this is like a question that we need to ask ourselves. What's happening with the model that we're currently building? We know that artificial intelligence is something that we're starting to get familiar with. 2 years ago, we were talking a lot about AI not being used, or you do a project and then you never deploy it. But what is the next step these days is something that's even more drastic. I would say personally, I was shocked to hear that most projects were not put in production. But nowadays, it's even worse because Gartner says that estimates that 85% of projects will deliver erroneous outcome. So here, this is, in my mind, this is even worse because it's better to not have a tool than to have a tool that return errors or inaccurate predictions. And what can we do to prevent this? So this is essentially what we're going to talk about. This is something that's really important to me, and I hope this is also important to you to avoid doing these mistakes in a future project. So the objectives, a little bit like what was written in the invitation. We'll stick to this because this is those are our 3 valid objectives. So first, we'll talk a little bit about validation of your model. Why is it important? We'll touch on that a little bit. I hope that it's going to resonate. And then we'll go a little bit deeper into the quality evaluation process. So what should we expect? What should a quality evaluation process look like? and then we'll talk about how to implement such process in your team. I'll try to not be too technical, but by nature I'm a geek, so it might be a little bit too deep. But if you have any questions, please feel free to ask later on, either in the question during the question period, or by email. So usually when I talk about machine learning, I'm usually referring to this picture. This is not the prettiest picture, but this is the most accurate one. Often in an organization, we'll hear the data science team, they say, you know what, I have a great model. Yeah, my model is performing so well. And even early in the project, you just started and the team already says, you know what, yeah, I'm able to solve this problem. I'm able to do a correct prediction. And then it can be during the project lifecycle, or it can be after, when the project is delivered. Then you realize that it didn't really work. It's like the myth of the fisherman. You think you have a big fish, but it's like it's a shoe, or it's a tire. So it doesn't work, and usually it's because it's a complex project. So I'm not talking against the data science team, but it's because it's a really complex problem that we're trying to solve, and usually it's easy to be misled by some of the problems that might happen during the project. So let's come back a little bit and talk about the performance. What does it matter? And here I'm going to talk a little bit more high level. Why do we need to make sure that we're delivering performant project, or project of good quality? So first of all, if it's a little bit like an onion, it has several different benefits to several different stakeholders. So at first, the project team is definitely going to benefit from a quality project. So it's a streamlined execution, because if you're able to deliver quality, you don't have to do a lot of redos, or you don't have to rush into fixing things when the project is delivered. So you make sure that you have a good project delivered as per the requirements. If you're, like, for instance, I'm the head of data and transformation, so I have a lot of different projects ongoing, and I want to make sure that every one of my projects are as good in terms of quality, and having a good process. So things that we're going to talk today allow me to compare my projects apple to apple, even if the use case is different, the task is different. Something might be an image recognition project, another one might be NLP or tabular data. Doesn't really care, because if you're able to quantify what's of good quality and what's not good quality, then you're able to compare, and you're able to create thresholds that are polyvalent despite the project type. Then if we go outside the pocket, like I said before, I'm a geek, so I know that things might not might go wrong from time to time. I'm able to troubleshoot a little bit the projects because I have experience. But what's happening when we go outside this technical pocket and to the stakeholders, so the end users of the project, the sponsor of the projects? They need to know, they need to feel confident about the project. And here, this is another example why when you have those fisherman myths, you lose confidence so fast, because it's hard to trust the team. Because if you say that something is good, and then they're able to point a very simple mistake, or something that's really clear to them, then the data science team will lose a lot of credibility, and that's it. And you clearly don't want that. And then finally, let's go even like the highest level possible. And this is a little bit why I decided to participate with to the ISO norm. It's because we need to think about the society, about the end users. Having a project, so having an AI system deployed will generate benefits, and you want to make sure that the whatever is deployed is good enough so that it does good by being precise, by achieving the business case, being able to achieve the benefit that you're looking for. And this is something that's important in society, because we're gaining adoption, we're helping democratizing the technology, and this is great because it creates a virtuous cycle. However, so that's great, and this is really important to make sure that we have this in place, this type of process. But a lot can go wrong. So here I'll put everything into perspective by going back and talk about, okay, what's a machine learning model? What's a system? How is it built? So first, and this is going to be 101, really basic, making sure that everybody's on the same page. So an AI system starts with data. So here we'll talk about historical data. With this historical data, a machine learning algorithm is going to learn trends. So let's keep it as simple as possible. It learns trends on the data that has been observed. And here we then validate the model performance. The model performance is essentially how good can these trends be transposed into prediction on new data. So if you're able to predict very well, it means that your trends are very precise, and based on these trends, you're able to predict new data points. And this is essentially here what I'm going to say. So when you have this model in place, the way you operationalize the model is by having new data. You then observe the trends in the model that has been trained, and then based on those trends, you make those predictions. It sounds very simple, but a common problem would be when you have bad training data, for instance. Garbage in, garbage out is a classic. It is something classic that we say in data science. So you need to start with good data. Irrelevant model trends. So here, for instance, I don't know if you have heard of overfitting. Overfitting, it's the equivalent of learning something by heart. So you try to learn every word so precisely, you forgot about the overall message that you're trying to learn. And this is exactly the same that can happen to a machine learning problem. The trends might not be generalizable on new data because they're irrelevant. If a business person or if a subject matter expert look into those trends, they understand very, very quickly that this won't work. Also, here you might think that you have a great problem, that you have a great solution to a problem, but if you incorrectly assess your solution, then it won't work. An example could be if, for instance, you have a machine learning on something we call unbalanced data. So, for instance, cancer prediction, you typically have a tiny ratio of people who have cancer and a majority of people who don't have cancer. This is great, by the way. We want to have this type of imbalance when we talk about cancer, but the problem is that if you think that your model is 99.9% accurate, just because it predicts everybody doesn't have cancer, your assessment is the performance has been assessed poorly, and it doesn't work. When we look at new data, it might be the new data might be unstable, might be different. Here we talk often about something we say out of sample data. So it's data that has been maybe trends have shifted, maybe there are some errors, technical errors, and it generates the data that is just not similar to what it has been trained on. So the gap is too far, and because of that, we're not able to predict correctly. On the business side, you might not be able to understand the subject matter expert or the end users might not be able to understand correctly what's going on, and it might lead to, for instance, ethical errors, security errors. It's possible, we never know, if we're not able to understand what are the most important variables explaining a prediction. And then finally here, even if your model is very good, your data is good, if you have miscalibrated your predictions, so you're not able to act properly on the prediction, then it all so the benefit that you think you're achieving might just not be there anymore. And this is why it's important as well to understand correctly what a good prediction is and what a bad prediction is. And that's a lot, but it's just the top of the iceberg. There's so much that can go wrong in a machine learning project. So here, all to say that we need to control the quality evaluation process. We need to have a tight process in place, and we need to make sure that this process is reflecting the quality that you're trying to achieve. I'm going to explain what it means. So when we talk about the process, it's usually going to be those 4 different type of activities that you'll need to put in place. So first, you need to understand what are the major activities that you do, because in a project lifecycle, the quality evaluation will not be continuous per se. It's not something that runs every hour like something in production. You'll need to plan some time in your project to validate the quality and avoid having bad quality for a long time, and then having to go back and change everything about the project. So you need to have different activities at different time. You need to determine measure and measurements. This is pretty hard, and we'll talk about that later, but I'll just mention some, I'll guide you through some of the measures and measurement, but we have another webinar in 3 weeks on the 16th, and we'll go further into this direction. Okay, so feel reassured that we'll talk about this a little bit later. You need to ensure comprehension of the output. The stakeholders will want to be reassured, will want to gain confidence. So it cannot just be a JSON with results and then the data science team being able to code everything and troubleshoot using the output of a quality evaluation tool or process. It needs to be reflected upon the stakeholders so that they're able to be to understand that everything went through. It's a good project, and we can go forward and deploy it. And finally, now that you have the right process, you can standardize it and embed it into your operations. So what type of activities will we need to do? So if we think about the execution phases, so usually a project will start with the project kickoff. And by all means, depending on your company, your type of activities, sometimes the names might change a little bit, but I think those phases are pretty standard. So we start with a kickoff, we understand the vision, we understand what's the problem that we're trying to solve. At that stage, we'll need to start evaluating already the data bias. One of the first activities that we'll need to do is to look at the data that is available and ask ourselves the question if the data is good enough to do anything about it. Okay, if you're not able to do something with this data because it's too biased, it's too the data is too messy, we need to raise a flag. There are also other risks that we'll need to evaluate at that stage. Can be the complexity. It can be too complex to be able to predict. It can be too sensitive. It might be very hard to adapt. So here are different type of risks that we'll need to highlight very early on. Then when we have identified what's the project like, then we'll fall into a proof of concept mode. So we'll start doing a POC, and our goal will be to demonstrate that it works. We can do something about it. We can resolve the situation. So here, what we'll need to do, it's something we call functional testing. This is being able to evaluate the suitability of the project. So, and I'll talk about it a little bit later, but suitability it's essentially, is AI necessary? Can I gain anything by using a complex model, or I can use basic statistics and get the same outcome? This type of testing is also necessary at this stage, because if we decide to go further, it means that the approach that has been accepted is generating additional benefits, and this is what's going to be implemented. So when we're in implementation mode, so what it means is, okay, we learn from the proof of concept, then we're making it available. So we pass from we're starting with a simple model, an end-to-end model, and now we're deploying an AI system from A to Z. And when we do this, this is where we need to have like a full overall quality evaluation, and this need to be a gate prior to deployment. So a best practice, even though you say, you know what, we'll just do a pilot, even if you think about making the outcome available to anybody, you need to have everything validated thoroughly, because you will lose credibility otherwise. And then when it's deployed, we're falling into continuous improvement mode, and then we need to monitor the performance. So here, two things that we'll need to monitor is data drift. So is the data evolving too much? And then there are so many trends that change, meaning that we need to retrain the model. And is the model degrading? So if the model is not able to do any good prediction anymore, we'll also need to do something about it. Excellent. So if we look at any one of those activities, so what we need to do at that stage is, and this is here, this is micro. So what we need to have model and data, or if you're just validating the data bias, for instance, you might just need to have a data set and the best practices that we'll talk later on, and we'll talk also in 3 weeks. With this, then falls the quality evaluation process that we're talking about today. And here is it generates an answer to a critical question. Is the performance acceptable, or is the quality acceptable? Sorry about that. This should be quality here. If the quality is acceptable, so sunny scenario, you did something right, you then are able to push it into production, to deploy your model. Otherwise, so you will need to so if it's not acceptable, you need to understand why. This generates, by the way, this portion, and it's normal. You'll always have some fix. So it's part of a normal process. If the problem is hard, you will have to improve quality a couple of times before you can deploy it. And this is a good news. It means that you prevented potentially a catastrophe if you would have deployed a model. And here, this creates a lot of learnings in your organization. It's important document those learnings, document the root cause leading to a quality issue, so that you can try to fix it proactively next time. And then when you do this, you fix it, so you're improving quality, and then it triggers another quality evaluation process. This is how it should be done. I know it can be painful, but this is, if you want to have quality in delivered, this is how you need to do it. Now let's talk a little bit about measurement, because this is not easy. So when we talk about measuring quality, we need to think about the definition of quality. And this is very hard, because it's not just a software per se. This is a very complex solution, and we need to. So those are 4 different characteristics that can be that can be translated into quality. So here I'll explain those a little bit, but this is just a portion of the different quality dimension. We're able to extract a lot more dimension of a quality system, but those in my mind are the most critical one to assess. First of all, suitability. Is your project is your project a good project? Are you generating the benefit that you're looking for? So this is a very, very legitimate question that you can ask yourself here. Reliability. So even if you're having a good project, if you have a good system, if your system doesn't work on different data, if it doesn't generalize very well, or if the performance drop every time there's just a little change in the data set, it's not very reliable. So it's going to be a challenge to have the benefit that you're looking for. And here you need to make sure that your system is more robust. So this is also another very important dimension. Discrimination. By the way, here when I'm using the word discrimination, we need to understand in data science that discrimination is normal. This is essentially why a machine learning model works. It's because there are some variables that you can use to discriminate towards a certain goal. So this is normal to have discrimination in a project, but you need to understand what's the discrimination type. You need to understand what's inside the black box, because you don't want to fall into the ethical risks and the harmful discrimination that can happen. It happened in a lot of different settings. It happened in banks when they started to look at the zip code, and then some zip code were proxy to look at the ethnicity of the person. You don't say ethnicity, so you don't have a column in your data set that says ethnicity, but the machine learning is so powerful that it's able to do these deduction, and even if it's not explicit, it's harmful for the population, and you need to be able to see this and act upon it. And then finally, maintainability. Maintainability, it's a little bit what we talked before, being able to monitor your model and your system. Sorry about that, because it has been deployed. And then when it's monitored, making sure that you have a project that you're able to maintain well. So when the data is shifting, you're able to catch it, you're able to retrain it, so that it's always refreshed and always up to date, without necessarily having to manually intervene, and also making sure that the performance is not just dropping without any human intervention or any intervention. Okay, something needs to happen. Machine learning is not as stable as, for instance, a software development solution. Even a software development solution, if you have a website and there are new versions of browsers, you'll need to validate against those new versions. So even a simple software solution need to be maintained. This is even more critical for a data science project, because the data evolve at an alarming rate and you'll need to act on it. And this is not easy to see those shifts. So you'll need to have the proper tools to be able to get there. So if we go back and talk about suitability. So here I'll just give you examples. So when you're trying to put a proof of concept together, so how do you validate that, yes, this is the right use case for machine learning, for artificial intelligence? So first, you want to test, you want to do some tests and see what's the performance based on the metric. And here, for your information, I'm using the plural because we should never have just one metric, and I'll talk about it. I'll touch on this in 2 minutes, but it's a bunch of metrics that you need to look to validate the quality of your model. So first of all, you need to ask yourself, okay, if I just randomly select a prediction, yes, no, what's my odds? So here a good example is head or tail, for instance. Head or tail, it's 50% chance. So you flip the coin, then you have 50% chance of getting a head or getting a tail. Here, if you're trying to do even the most sophisticated project, you'll get to the same odds, or you'll even get worse odds. Believe it or not, it's possible to even be worse than a random state. It's because you're trying so much to learn something that you cannot, because it's completely random. So here, this is for a first good test. This is a sanity check. Am I better than random state? This is like the lowest bar ever. Then after that, the right next step will be to test with a dummy model. The dummy model could be yesterday's value. If you're trying to forecast in the future, it could be the median or the average prediction, and so on and so forth. So there are different ways or different statistics that you can use. Oh, okay, I'm always going to use the average of the last week to predict something, and it might bring good performance. It might be very good and so simple to implement. So this is something that you should not skip. And actually, the dummy model is the minimum threshold. So usually, if you're able to beat the minimum threshold, then you see that, okay, it's a good thing. So it means that using machine learning is making a difference, is helping me getting where I need to go. But even then, there are a lot of different models, and you can have a simple model, or you can have the most complex model, and there's no limit. We see it with like GPT-3, BERT. There are no limits in terms of complexity. The only limit currently it's the processing time and the data set. So when do we need to stop? And here, the way we see it, it's by looking at the return. So when you go step by step, so what you'll see is that you probably, and this is not a rule because it really depends on your project, but you will gain, and then at some point, so when you start having more complex model, you'll see that you'll plateau. It's normal because there's a ceiling at some point, like a theoretical ceiling. It depending on the because it can never be perfect. Data and like data will always be a little bit imperfect, and you will never be able to capture 100% of the data. So This is why you'll never be able to achieve the absolute perfection, but you'll get closer to the perfection. And then when it's too complex, it will start decreasing, and it can decrease a lot. And why I'm saying this, it's because not only can you overfit, or you can have bad performance metric, but also when you start looking at all those other metrics, so the robustness, the more complex your model, the less robust it will be, because you'll have to maintain a very complex solution. You can have your inference speed. Having a small model will be very snappy and very quick to predict something, and a complex model will be heavy and will take time to make a prediction. So it can be a showstopper for you if you need to have your decision in a couple of seconds, and you need to take that into consideration when you look at your performance. If we talk about reliability, it's all about playing with your, so if you have some data and you do a model, how robust is your model? This is a good question, because if you only look at your training data set and you never look at the data, the live data, you might be very surprised. You can have some random noise. I don't know. You change your systems, and every data, so every data changes a little bit. Oh, so that create a problem. You might have new scenarios. Here, I don't want to surf on what happened 10 months ago, but the COVID-19 was catastrophic, but also for machine learning, it made most machine learning models unusable. Why? Because they were not ready to deal with such scenarios. We've never experienced something like this. And even I'm not saying that models should, because I think this one was really drastic, but models, you could get closer, or you could reduce the performance drop by creating new scenarios. You add noise to your model, extreme noise. You could even think about hacking your models. Right now, we start to see this with adversarial examples. This is a way people can hack your model, and you can hack your model too and see how it performs. And finally, also looking at the uncertainty. You might have a good performance, but if you have a very high level of uncertainty, as soon as you deploy, then it was already uncertain, so you might be in trouble later on. We'll talk also about model discrimination for a second here. This is a slide that's quite hard, and you know what? I did it on purpose, because being able to see the model contribution, or the feature contribution to the model, it's never easy, and you need to find an easy way to do that. It's not true that you cannot do this. It's not true that deep learning cannot. So it's not true that deep learning is a black box and you cannot try to explore what are the biggest driver to your model. It's not true anymore, by the way. You can do this. There are some very useful tool and very tool that have been validated that you can use right away. Okay, so this is an example of measuring discrimination. So for instance, if we look at the first variable, so this is about chest pain, and what it says here is that if you have a high chest pain or a low value of that variable, you can see that this is really discriminant. So every time there's a high value in this variable, so the first variable, it means that the model will be reducing, or you will predict a 0, and then when you have a low value, in this variable, you tend towards a higher one. So if it's binary, so you predict that something is going to happen or not. Okay, so this is really discriminant. And here it gives me a lot of information. So for instance, we can see here the gender if we go down. This is not as discriminant because they're near zero. So my line in the middle, it's a zero. So it's near zero, but what it says is that when the patient is a male, you tend to be towards zero. And so this male thing is helping the model get better. And here, asking a subject matter expert will be a good thing. And if the subject matter expert look at every one of those variables and agrees, it's a great sign. It means that your model has trends that seem to be useful. Then when we talk about maintainability, and here this is a good quote from Towards Data Science. The moment you put a model in production, it starts degrading. This is true. It's you're trying to beat the clock with your model, because the world is evolving, and a model, it's something that you train at one point, and then you predict on it, and then you retrain it. But you have always retrained, so you're always in the past. And this is why it's so important to make sure that your trends are robust and that you're able to maintain easily your model. Okay, this is not true that your model is evolving in real time. It's true if you're starting to talk about reinforcement learning, but even reinforcement learning, it's never case by case. It's going to take a high level of it will take a lot of observation to be able to adapt properly the prediction. So here, when we talk about data drift, it's like your model has been trained on something that's so clean. It's like living at your parents. You're used to like this very simple life, and then when you're by yourself, you see that, oh, I should have stayed home at my parents, because it was I was protected against like all the nature's element. And here you're by yourself, so you see changes in your systems, new trends, COVID-19, financial crisis. It can be a shift that happen over time. When there's new technology, when there's when the iPhone happened, it took some time for the trend in electronic to change, because it takes time until the critical mass is getting access to the technology, or there are some overnight trends. But when so if you have if you're having, so in COVID, for instance, so sometimes legislation can prevent you from going to a restaurant or to a store, and it's happening overnight, and it completely changes your pattern, not only for the restaurant and the store, but if you're an internet service provider, it will change the way people are using your service, because people are at home. So it's happening overnight. You need to be able to act on it. So now that you have and by the way, this is just a bunch of examples. So now that we talked about the process, and I hope that you'll put this in place, where we talked about some measures, some dimension that you need to look into. Now, what's happening? So first, you need to develop output that is useful to your stakeholders. One key that we've seen at some best practice that we've seen at Snitch AI. First, it's very useful to create a global quality metric. It's not a must do, but this is something that's very useful, because you're able to compare two versions against each other. So being able to create that global quality metric is super useful. But also, it's being able to break down your metric into subcategories. It's also important. So if you look at the image, so let's say here we have 67. A score of 67 means that, I don't know, depending on your description, but here it could be, you know what, we suggest you to put in prod, but to monitor or to review to review the other dimension of your of the quality of your model. And here would be the different different section with a green, yellow, red. So here, even though you have a 67, but you have some opportunities for improvement that have been identified, and then it's more granular, so people will be able to act on it more easily. But it's important to keep this simple for your stakeholders. So, you know, you'll have to deal with two sides of the coin. You want to give as much guidance to your development team, but at the same time, you need to keep it simple to your stakeholders. So here, this is a problem, and this is why what I would suggest you is to have a business output for your stakeholders, and also to have a more concrete set of recommendation for your development team. And please make sure that the quality evaluation process should not become a troubleshooting process. You need to use this with care when you have a new version, a new final version that you want to validate. You cannot just say, you know what, I'll just test in loop my model until something works. So it needs to be a last step when you're ready to put in production. So to recap, quality evaluation, this is something that's critical. We're in the far west right now. Things are not stable. You look online and you still see some people who are suggesting you to produce a machine learning model and not even use a validation or test data set. It's still there. You can reuse the code, and then you miss the step where you need to validate your model, and then you think you have like a very good solution. It's the far west. You need to be able to structure your practice, and this is how you'll gain you'll get to a successful deployment. Okay, and you'll be able to have a succession of good projects under your belt. It's again, it's not just one performance metric. I see this all the time. You have a classification problem. You're deciding to use AUC, so you know, area under the curve, because accuracy is not as is not necessarily the proper metric, and you think this this is enough for you to see to have a clear view if your model is of good quality or not, but this is not sufficient. Even if you start getting there, you need to think more holistically about the quality of your system. So what's happening if your data change? What's happening on the long run? What's happening if some situations are not looked into? What's happening if the end users don't understand the main drivers of your model, etc. So this needs to happen. And then finally, even if you have the best evaluation process, you need to give insights to your stakeholders, because we're still far from a democratized technology. We still need to get there, and the way you can get there is by reassuring your stakeholders and demonstrate that your project is in good care, and that you can expect the return to be positive because you have validated without any. So it's never it's never a perfect validation, but you made a good enough evaluation to be confident about the results, and then the end user, if you're using their language to demonstrate this and to share this message, will understand that they're in good care and that they can trust the model that you're about to deploy. So this is it for me. I would like to thank you very much, and I'm available. I'm all ears for questions.
Perfect. Thank you. Thank you, Olivier. Very insightful as always. So we'll open up for the questions. We don't have any right now. So if you want to write any questions at the bottom of your application, your Zoom application, you should see a section called Q&A. You can simply write your questions there, and we'll take them one by one. I did receive a few chats from people asking if this is going to be recorded. It is. It was recorded, and we will send it to you after. So you can send off your questions, and we'll take them as they come. We'll just wait for them to come in. There's none right now, but in the meanwhile, I'll do a bit of a shameless plug. We have another webinar, as Olivier mentioned, in 3 weeks. So in this one, we're going to go a bit deeper into the validation framework that we have. So, like Olivier talked, how to measure discrimination, measuring reliability. So introducing noise into your model, for example. How to detect drift. So we'll go into a bit more details about that model and look into Snitch AI a bit more as well. Perfect. So we have some questions for you, Olivier. Guillaume is asking, I'm curious, why you say that validation is not troubleshooting? You explained it a bit, but I want to know more.
The difference between the two, it's because it depends on who is impacted by it. Troubleshooting, it's something that will be so the troubleshooting is a necessary activity throughout the development, and this is so the objective is a little bit different. For troubleshooting, it's trying to have the best solution, and quality evaluation, it's making sure that the solution you're deploying is of good quality. So if you're waiting until the end to troubleshoot, there's a problem. You need to make sure you have the right tools to help you developing your model along the way, so that when you fall into the quality evaluation process, you already have a good and valid solution that is ready to deploy. You know, it's a little bit painful, but this type of gates is important. It's super important. So you have one model, you validate it, and then it can go into deployment phase. It's critical. It's a little bit the same thing. So it comes back to validation dataset versus testing dataset. So when you want to validate it, when you want to validate your model along the way, you're using the validation dataset. This is great. You test it all the time. Sometimes you randomize it a little bit to make sure that you're not using always the same data. But at the end, what you'll do, you'll use your test dataset. This is exactly the same thing we need to achieve here.
Perfect. Thanks, Olivier. We've got another one from Arjun. When looking for overfitting, what are some tools used by data scientists to check for this? Can you only find out after the deployment?
This is a great question. For overfitting, there are different ways you can do this. In fact, what's interesting with overfit is that as complex as it is, you can find smoke wherever you want. You know, there's pas de fumée sans feu. So when there's a fire, there's smoke, and you're able to find this by looking at a lot of different things. When you use a separate data set, the test data set, for instance, that you have not used before, it should be able to help you out. But there's even something better, because sometimes the data set can be, you can have like duplicate in your data set and everything. So you can, if you're trying to use a interpretability technique, you'll be able to see that the main drivers or the main trends that you have identified with your model are incorrect. This is pretty typical. So the first the main features don't make any sense to the subject matter expert, so it should ring a bell. Another one, and this one we'll also talk about this later, but if you add just a little bit of noise into your data set, and it makes a big difference, a big drop in your performance, usually there's also a problem there. It means that there's probably overfit involved in your model. So those are ways you can get there. There are also other type of analysis, like if you're doing deep learning, looking at the history by epoch. Usually you'll be able to see just the learning curves. But anyway, so there are a lot of different ways to be able to validate this. And I agree with you though, well, because I suspect this is your opinion. This is not easy when you're just looking at the quality measures or the performance measures that are known today, to validate to identify if there's a little bit of overfit or not. But when you're looking outside those, it's easy to spot.
Awesome, perfect, perfect, Olivier. And Anjan, if you didn't notice our accent, Olivier made it clear that we're from Quebec by dropping a bit of French there. Perfect. We got one last question, actually another one that just came in from Andre. The main drivers are always derived by the models?
Yes. So when I'm saying the main drivers, then it depends here if it's a philosophical or if it's a discussion about the machine learning model. So you can say philosophical in the sense that you might want to identify the main drivers upfront and only use those. But with deep learning, it's a little bit less. So the trend right now in the industry is to go further from we call it feature engineering. So usually feature engineering mean that you're finding those drivers, and then only the best drivers are used in your model. And now with deep learning, it you're able to deal with noise more easily. So people, what they will do, they will instead of work on the features, they will take everything and then they will work on the parameters instead, to be able to be more to be optimal then. So here, in other words, the trend in the industry is that the model will find the most impactful variables. And then here, this is why it's important for validation, for an interpretability technique. It's because these technique will show you to what's the importance of those variables, and then you can be in agreement or not with the model. And this is where it starts being really interesting. Even if you found and you cherry picked the variable based on the importance, it's possible, again, to piggyback on the Martin's question. If you overfit, even if you think those 3 variables should be the most important, but if you overfit, it's possible that those will not be in the important section, like will not contribute to the prediction, because there's a problem that you need to resolve before.
Great. We've got one last question here from Simon. how can I help my model? How can I know my model will perform on new data in production?
This is a good question. In production, so first, from a process standpoint, what you would need to do is you would need to validate that your model, that your production data is similar to your training data. And it sounds stupid, but this is a major problem. I've been working in a fintech company before, and one of my problem is that when you look at the financial transactions, so the expenses can be a negative number, or it can be positive, but in the passive column. And here, what happened to me, and that was like a big problem, my training data was transformed, so every numbers were negative if they were expense, or positive if they were revenues. But in real life, in production, the numbers were positive if they were revenues or expense. So it doesn't work. So you need to do this first. If then you validated it and you're okay, still you need to validate that your model is robust enough. And the way you can validate is if you add a little bit of noise, if you're trying to play with the data, you create new data set, you can create test cases, and see how it reacts. So if you add a little bit of noise, and your model is not it is still performing well, then it looks promising, and it means that even in production, if your data changes a little bit, and by all means, it's important for your model to be able to react on new data. This is why you have this you have an AI system in place, is to evaluate new data set. So but that's how you'll be able to get there and have a feeling if you're okay with your model prior to the deployment, because you don't want to test blindly an AI system in production.
Perfect. Well, this ends the question period. So we want to thank everyone for joining us today. If there's any more questions that came up that you want to ask us, feel free to send it to us. We're more than happy to answer them. But that's it. That's it for us today. And again, thanks for joining us.
Thank you very much.